building because it was sort of flat. It's handy. We're going to have water out here. We've only had pond water, and so we'll actually have drinking and hand washing water here, and so it'd be nice to have it close to the shed. And we had good drainage, so this seemed like the right place.
We know that this point is where we want to have it. So what we can then do is, if we know we have the right length, we can have, first of all, we should say we can have the right lengths with these. Both these sides can be 96 feet, and both these ends can be 35 feet, and we can still not be square, right? So we could be sitting like this, or like a rhombus or something like that, and we definitely don't want to be there. So what we want to do is make sure that we have right corners in each, right angles in each corner. And there's a couple ways to do that. So one of them would be that we can take, we ended up only having 100-foot tapes, but we want to basically make our diagonals equal. So if this corner to that corner is the same distance as that corner to that corner, we know that we're squared up. So the way we can figure that out is we can all remember math and the Pythagorean theorem, which is what?
3, 4, 5.
3, 4, 5, or a squared plus b squared equals c squared. All right. So we can say we were 35 across and 96 long, so we take 35 squared and 96 squared and add them together. And then to get our diagonal, that would be c squared, and it ends up for a 35-foot house by 96-foot house being about 102.2 feet. So just a little bit over 102 feet. So what we can do is measure right that corner to that corner, look for 102, a little more than 102 feet. Same thing here, get the same distance, and we would be all set.
So then we're going ahead and laying out and pounding the ground posts into the ground. We don't typically cement them. It's just another step, another expense, and we haven't found that it's necessary.
This is how we used to do it, right? You'd hit it a few times, you'd put the level here, and then you put the level here, and then you take it off, and someone would pound it again, and then you'd do this and do that. And then we were at the hardware store one day, after we had built 15 of them, and found that for like $5 you can get a post leveler. And so these are really nice because it just fits on the post, goes around like this, and you can see, right, you've got this leveling it this way and this leveling it this way. So usually what we do is get the posts all driven partially, and we aren't driving them to our finished point the first time down. So we usually drive them, I think with these ones we drove them till they were about this high, so you're driving them far enough in that that they're going to stay enslaved, they're going to be pretty sturdy, but if you needed to adjust them or move them out, or that we're okay to do that. So we usually go ahead and set the 4 corners that way, and then what we do is come in with a string like this, and you can do rebar, you can do these types of stakes, you can use batten boards if you want to build batten boards. Basically we do that in all the corners. And then we take mason twine. You don't want to use like baling twine or something like that. You want something that you can pull really taut, and mason line tends to work the best. And basically we're doing this same pattern, right? We're wrapping it and sending it down one side. You can see we went around and basically around here on the other end, and then came across that end. And then we had it also running down this side, but we ended up cutting it by accident when we put the last post in. This is our guide for where our posts are going to go. So we know that this is just touching this edge of the post, and so then we can measure out with a tape where our posts are going to be. So for this particular house, it was 6-foot spacing. Most of the ones that we've built are 4-foot spacing. And so we basically run a tape and then can mark where each of these are going to go. And then when we stand them up, right, we're making sure that they're vertical or they're plumb both this direction and this direction, and that they're just touching the line. And basically you can put a line level on here. A line level works really well, and they're really affordable. So basically what we do is make sure this line is level, and then we can go down and we can set that line going across, bring it down to touch this line, and then level it across and move that down. So, and then the same thing coming down this end. This becomes a level plane and becomes our point of reference. So we can drive the post to that point, or that marked point. So we know it's level all the way across. So what we then do is come on and mark where we want on this post to drive down to. So here we made a 4-foot mark down, and then on all the posts. And then we basically just took that mark down to that line. And so then what that does is lets us say, okay, this line, let us get them in a straight line this way, and then the mark in that line, let us get all the tops to the same level.
Then we're going ahead usually and assembling the rafters or the bows. When those two steps are done, we go ahead and we stand up those bows or rafters, kind of going down. So for Laura's, I would say we had enough hands that we could go ahead and start putting on all the purlins in the same day and not worry about it blowing around too much. So the big part of it, I guess we could say you could do the purlins or you could do the ridge cap. The big part of it is making sure that you don't put up the bows and then kind of leave them for the night and come back the next day without having them attached in any way. Because if it gets windy, there's a good chance that they can twist and bend, and that kind of keeps things in place. So usually the first day would be up to putting the bows up and then putting the ridge cap on. For the one that we built at Laura's farm, it was a new design, and they had some wire, some high tensile wire, or braided wire that went from the corners up to about the third or fourth bow, and that was kind of doing two functions. I think the main one was acting as a wind brace, and they weren't using trusses on that house because the pipes weren't round or square. They were actually open, so it almost looks like an upside down gutter, or they call it a hat cap. That steel, it was strong enough because of the design and because it was roll form steel that they didn't need the trusses on that. But the majority of designs, or the majority of houses and manufacturers are using cross bracing or trusses at 22 or 26 feet and wider. We want to go ahead and plumb the structure. So what we're doing is dropping a line from the peak and running one across from bow to bow on the end, and we usually do it on the outside of the house, and then you're usually pulling the house one way or the other to plumb it up or make it straight with itself, so when you put the end walls on, they're vertical as well. So we usually tie it off to either a car or a tractor, some sort of ball, where we can then drive the tractor or the car and hold it in place while we put on the hip boards and baseboards and wind bracing. After we plumb it, we're going ahead and doing the baseboards. And the hip board. And the wind bracing. Then we're kind of looking at the end walls, and depending on the design, either framing them with lumber, framing them with metal, covering them with plastic, covering them with polycarbonate. Those are all different options that you can do. And it's usually kind of free form. They don't really tell you, this is the end that you should build. They usually just say, frame it out. So, a good thing is to look at other hoop houses or talk to the manufacturers and see if they have a suggested design for the end wall. So after that, we're attaching the end wall, bury our vertical 2 feet in the ground so that we have some support. We don't want to just end them right at ground level, otherwise when the wind gets blowing, they really get blowing back and forth. And then the next step is covering it with plastic.